So today I built a couple logic gates out of NPN transistors. I have them hooked up on a breadboard to an Arduino. All the Arduino is doing is supplying power and looping through the possible input combinations. I have these two LEDs to indicate the inputs, so input A and input B. It's looping through all four possible combinations. And then I have four basic gates. I have an AND gate here, an OR gate here, a NAND gate, and a NOR gate. And the output is shown by the LEDs. So first I'm going to go through a basic what is an NPN transistor. So this is pretty much an NPN transistor. It's got 3 pins. The pins are the collector, the base, and the emitter. And what it is, it's pretty much just a switch that's controlled by the current into the base pin. So when the current into the base is 0, the switch is off, so no current flows from the collector to the emitter. But when there is a small current going into the base, it allows for a larger current to flow from the collector into the emitter. So the first schematic we're going to look at is the AND gate. So here we have the A input, the B input. I have 2 resistors here because the base only needs a small amount of current to turn the switch on. And too much current could burn out the transistor. Then I have power, I have ground, load resistor, and output. So if we look at the truth table, I guess we'll go one by one. 0, 0, so A0, B0, both transistors are off. No current flows through either of the transistors, so the output is low. If we look at 0, 1 or 1, 0, only one of the transistors is on, so current either stops here or flows through this one and stops here, so the output is still low. And finally, we look at 1, 1, where both A and B are high, so that means both transistors are turned on. So the current will flow through the first one, through the second one, and into the output. So the output will be high. The next circuit we're going to look at is the OR gate. So the OR gate, we're using 2 transistors, A and B input with the resistance. So here we have the power hooked up to the collector of both transistors, and the output is hooked up to the emitter of both transistors. So if we look at the truth table, 0, 0 or low, low means that both are off. So no current will flow from the collector to the emitter on either one. So the output is low. And if you look at either of the next 3, where one transistor or both transistors are on, then the current will flow from the collector to the emitter on either one and flow out to the output. And so those 3 choices are all high. Next we're going to look at the NAND gate, which is the complete opposite of the AND gate. So here you'll notice that we have the output up at the top. So if we look at 0, 0, alright, actually we'll look at any of these 3, the first 3. So this ensures that at least one of the transistors is off. So with any of them being off means that the current will not flow from the collector to the emitter on either one. So then the current will have to flow from VCC into output. So these 3 will be high. And looking at 1, 1, meaning both transistors are switched on, the current will flow through the first one, through the second one, and into ground. All the current will flow into ground, so output will be low. The final circuit is the NOR gate, which is the complete opposite of an OR gate. So again, like the NAND, we have the output up top. So if we look at the truth table, 0, 0, meaning both are off, there's no current flowing through the first one, no current flowing through the second one. So no current is flowing into this point. So all the current flows through VCC and into output. So the output is high. Now with the next three possibilities, they ensure that at least one of the transistors is switched on. So at least one of the transistors has current flowing through the collector into the emitter. So if this one's on, the current flows through and goes to ground, which means output 0. This one on, same thing. Flows through current, or flows through collector, into the emitter, into ground, and the output's low. And if both are on, well, same thing. All flows into ground, and it's low. So taking one last look at the circuit, we have the AND gate, which only turns on when both A and B are high. So right here. We have the OR gate, which turns on whenever A or B is high. We have the NAND gate, which is the complete opposite of the AND gate. So we can really just look at these two LEDs, and if one's off and the other's on, which with each case, then we know it's working. And same goes for with the NOR gate. We look at the OR gate and the NOR gate, and the LEDs should be inverted.